Assalamualaikum warahmatullah. Today we shall discuss regarding atomic structure. We have already discussed regarding atom, subatomic particle, atomic number, atomic mass unit, then the Rutherford's atomic model, its limitation, Bohr's atomic model, its limitation, and then we have discussed regarding Pauli exclusion principle, Hund's rule, electropositivity, electronegativity, etc. Today, we are going to discuss some other aspects of this atomic structure. These are different atoms, carbon, oxygen, hydrogen, nitrogen, sulfur, sodium, calcium, potassium, iodine, chlorine, phosphorus, etc. And you have already been acquainted with the subatomic particles of the smallest particle in the element. These subatomic particles are proton, neutron, and electron, etc. Nucleus is consisted of only proton positively charged, neutron negatively charged, and it is surrounded by a cluster of electrons, which is negatively charged. And nucleus is surrounded by different shells or orbits, first orbit, second orbit, third orbit, principal quantum number 1, principal quantum number 2, principal quantum number 3, principal quantum number 4, etc. And we are also acquainted with the terms isotopes. Isotopes are atoms with different masses. The mass number of atoms differs due to the presence of different number of electrons, different number of neutrons, and here two isotopes are shown of chlorine. One has atomic mass 35, another has atomic mass 37. Amongst which, since chlorine is atomic number, its atomic number is 17. So their number of neutrons are 18. Here its atomic mass is 37. So number of neutrons are 20. Now, regarding the subatomic particles, proton, it has one positive charge, neutron has no charge, electron it is having one negative charge. First cell contains maximum 2 electrons, second cell contains a number of 8 electrons, and third cell is also containing 8 electrons. Electronic configuration of different elements like calcium, sodium, then your oxygen, chlorine, silicon, and boron. It is mentioned here. Calcium has 20 electrons. Its atomic number is 20. Sodium has 11 electrons. Its atomic number is 11. Oxygen has 8 electrons. Its atomic number is 8. Chlorine has 17 electrons. Its atomic number is 17. Silicon, atomic number 14, has 14 electrons. Boron, atomic number 5, has 5 electrons. In case of nitrogen, whose atomic number is 7, in first cell there are 2 electrons in 1s level and 5 electrons in 2s and 2p levels. In 2s level there are 2 electrons and in 2p level there are rest 3 electrons. So 2 plus 3 is 5 and plus 2 is 7 electrons. Total 7. Here in calcium, in first cell there are 2 electrons, in second cell 8 electrons, third cell 8 electrons, in fourth cell 2 electrons. In sodium, in first cell 2 electrons, second cell 8 electrons, and third cell 1 electron. Then in oxygen, first cell 2 electrons, second cell 6 electrons. In case of chlorine, first cell there are 2 electrons, second cell 8 electrons, third cell 7 electrons. And in silicon, first cell 2 electrons, second cell 8 electrons, third cell 4 electrons. And in boron, first cell has 2 electrons, then in second cell there are 3 electrons. Atoms of different elements has different numbers, and this is known as its atomic number. Atomic number is the number of protons in the atom. Atoms have very small positively charged nucleus with negatively charged electrons outside the nucleus in energy levels. The electrons live in different energy levels. In ground state, it is remaining in first cell, or the outermost cell that is different for different atoms. And when it is excited, then it is excited from its ground level to the next higher energy level. Rutherford's atomic model says that at the nucleus, the atom is massively positively charged. This charge is different for different atoms. Nucleus is only a minute fraction of the total volume of the atom. It has a lot of empty space around the nucleus, and electrons are revolving in the cloud closed orbits around the nucleus. But theory of electrodynamics didn't support it. It says that when a charged particle moves against another charged particle, it usually loses energy. So ultimately, it is dropped to the nucleus. In case of atom, where a charged, negatively charged electron is moving around a positively charged nucleus, so ultimately the electron will subside with the nucleus. So that's the proposal for Rutherford's electronic atomic model doesn't support this. Bohr's model explains absorption and emission spectra. Different spectral regions were assigned with Lyman, Balmer, Trasim, Brackett, and Kund series. Electrons are revolving around the nucleus. And he also supported that when electrons are moving, it may absorb energy, and when it is absorbing energy, then it is jumping from the ground state to the upper energy state. That is excited energy, electrons are going to the upper energy state, and when it loses energy, then it comes down to the lower energy state. The difference between the energy state E2 minus 1 is 8. And this is related with the n h divided by 2 or twice pi, where this is the h is Planck's constant, and twice pi related with the orbit, that is the radius of related with the orbit, and n being any integer, that is 1, 2, 3, or 4. It is quantized. Limitation of this Bohr model was proven by Schrodinger, Heisenberg, and de Broglie. They proposed that atoms are not planar, as mentioned by Rutherford or Bohr. Rather, it has three-dimensional configuration, and they, through quantum mechanics, mathematically, gave the shape of the different orbitals where electrons resides, and the shape of the orbital is determined by another quantum number, that is its azimuthal quantum number, where the principal quantum number is determines its energy state or different energy state. This is the shape of S orbital. This is spherical orbital. Shape of orbital is dumbbell shape. P orbital is dumbbell shape, and this is D orbital. These are mathematically deduced by Schrodinger, and 1s, 2s, 3s, all S orbitals are like this. Similarly, all P orbitals, 2p, 3p, 4p, 5p, all P orbitals are like this. Similarly, 3d, 4d, 5d, all D orbitals are like this. D orbitals are having 5 species. One is dx square minus y square. Another is your dz square. Another dyx, dyz, and another is dzx. These 5 d orbitals are lying in the space as x square minus y square is one in x-axis, another in y-axis, and z-axis is free. In the z square, only in the z there is the orbital, and these two are free. Similarly, in dxz, these two orbitals are in between x-axis and z-axis. And in dxy, these orbitals are in the plane of xy plane. In dyz, these orbitals are in yz plane. Principal quantum number are expressed by digits 1, 2, 3, and it's specified the energy of the orbital. And the number of electrons in total number of orbitals in a given orbit is n square. For example, in number 1 orbit, it is only 1, and that is your known as principal quantum number. Only one, that is for principal quantum number 1. It is 1 minus 1 is 0, and this 0 represents s orbital. Azimuthal quantum number, this is denoted by L. So it is always less than 1 by its magnetic, its principal quantum number. So if n is 1, then L will be 0, only 0. This is 1 minus 1 is 0, so it will be 0. Its digital value will be 0. And alphabetically, this 0 orbital is represented by S. This is 0 by S. And when n has value 2, then L may have 0 and 1. And 1 is for p orbital. When n is equal to 3, then L may have value 0, 1, and 2. So, and 2 is d orbital. When n is 4, then L is up to 3, 3, 2, and 1. 3, 2, 1, and 0. 0 is S, 1 is P, 2 is D, and 3 represents shape orbitals. In this way, the azimuthal quantum number shows the shape of the orbital. And magnetic quantum number, it may have value twice L plus 1 for azimuthal quantum, which azimuthal quantum number is L. That is, if the azimuthal quantum number is 1, then it will have 3 values, plus 1, 0, then minus 1. So in this way, for azimuthal quantum number L, we will have value plus L minus 1, plus L minus 2 up to 0, then 1, 2, 3 up to L. So these are the 3 main quantum numbers as assigned by quantum theory, and Einstein kept through its relativity that electrons may be either positively oriented, positive its momentum, positive, or its momentum may be negative. And thus, it gave 2 spin values. One is plus up, another is minus up. When in an orbital there is only a single electron, then it may have plus up value or minus up value. But when there are 2 electrons, then one will have plus up, another will have minus up. Pauli exclusion principle, who got Nobel Prize for that principle, he expressed that no 2 electrons in the same atom can have identical wall 4 quantum numbers. And another chemist who gave another rule that in the orbitals of an atom, where the orbitals are of equal energy, then maximum number of electrons will remain there as unpaired form. For example, in P level of an orbit, there are 3 orbitals: Px, Py, Pz, plus 1, 0, minus 1. In these 3 p orbitals, 3 electrons may remain in unpaired form. When there will be 4 electrons, then 1 will be paired. When there will be 5 electrons, then 2 will be paired. When there will be 6 electrons, then all the 3 will be paired. Similarly, in d orbital, there are 5 orbitals of equal energy level: dxy, dyz, dzx, dx square minus y square, dz square. And 5 electrons may remain simultaneously in unpaired form in these d orbitals. If there are 6 electrons to be occupied, then 1 will be paired. For 7, 2 will be paired. For 8, 3 will be paired. For 9 electrons, 4 will be paired. For 10 electrons, all the 5 orbitals will be paired then. Similar cases in f orbitals also. So these are 2 major principles. One is your Pauli exclusion principle, another is your Hans rule. This is to be memorized. The electrons in the outermost shell are the most energetic, and these are known as valence shell electrons, and this determines the valency of an atom. Elements of similar properties generally have similar outermost electronic configuration. Thus, alkali metals have one electron in the outermost level. Alkaline earth metals have two electrons at the outermost level. These are your alkali metals: 1s2 2s1, sodium 1s2 2s2 3p6 3s1, potassium 1s2 2s2 2p6 3s2 3p6, and 4s1. So outer configuration of the outermost shell is similar. That is, one electron is there. In case of your lithium positive, that is, which is from where one electron has gone, then this 2s electron is due to this is outermost electron. This absorbs energy, and this energy is known as your ionization energy, and absorbing that ionization energy, it is ionized, and its electron configuration become 1s2. Similarly, when sodium is ionized, its electron configuration becomes 1s2 2s2 2p6. When potassium is ionized, its configuration becomes 1s2 2s2 2p6 3s2 3p6. Tungsten metals are also metals, and they have electrons in the d level, and when one or two or three electrons from these d levels are going out, then it becomes either monopositively charged or dipositively charged or tripositively charged, etc. Thus, these are known as B group elements, and the main group elements are known as A group elements or representative elements. And the number of electrons in its outermost shell represents its group number. As we have mentioned, the principal quantum number, when it is 1, then azimuthal quantum number is 0. When principal quantum number is 2, then azimuthal quantum number is 0 and 1. When principal quantum number is 3, then its azimuthal quantum number is 0, 1, 2. When principal quantum number is 4, then its azimuthal quantum number is 0, 1, 2, 3. And this azimuthal quantum number 0, it corresponds for s orbital, it corresponds for s orbital, it corresponds for p orbital, this for s orbital, this for p orbital, this for d orbital, for s orbital, for p orbital, for d orbital, and for f orbital. In this way, for each orbital and corresponding to the principal quantum number, there should be a magnetic quantum number. There only one orbital is there. This is known as s orbital. So its magnetic quantum number will be also be 0, and it will have two spins as your plus up and minus up. There, the principal quantum number is 2, but azimuthal quantum number 0. So magnetic quantum number is also 0, and for this there will be two electrons. One will be a plus up spin, and another will have minus up spin. When principal quantum number is 2 and azimuthal quantum number is 1, then there will be again minus 1, 0, and plus 1. These three sub atomic levels, P subsidiary quantum number or azimuthal quantum number for 1, there will be Px, Py, and Pz. These three orbitals having digital value -1, 0, +1, and alphabetically one is known as px, another py, another pz orbital. For principal quantum number 3, 0, 1, 2 will be its azimuthal quantum number or subsidiary quantum number, and for subsidiary quantum number 0, its magnetic quantum number will also be 0. For 1, it will be -1, 2 + 1, 1, 0. That is twice 1 + 0, that is 3. For 2, it will be twice 2 + 0, that is 5. One is dxy, another dyz, another dzx, another dx square -y square, another your dz square. In this way, for 4, there are so many quantum numbers. These are to be memorized and remembered, whatever it is. And on the basis of these orbitals, the electrons are distributed initially in 1s level, then 2s level, then 2p level, then 3s level, then 3p level, then 4s level, then 3d level. This is how, due to above principle. After 4s level, 3d level comes. So in group A, it is known as alkali metals group. These are very reactive, never found in nature. React readily with water and explodes. Group 2A, known as alkaline earth metals, these are also reactive. Other metals occur only in the compounds, react with oxygen in the general formula EO. Then metalloids, these are in between metals and non-metals, and though they show metallic properties, they also sometimes behave like non-metals. Principal quantum number, azimuthal quantum number, and the subcells orbitals which are associated with these subsidiary quantum number, and these are magnetic quantum number for these subcells, and total number of electrons are shown here. So these are the shape of the orbitals, and we have mentioned that different spectra that are observed: Lyman series, spectra, Balmer series, Paschen series, bracket series, cone series, and some are observed in ultraviolet region, some are observed in your infrared region, and some are observed in visible region. And in case of Lyman series, all from upper electrons from all upper state come to the first energy level. In Balmer series, electrons from the upper energy states come to the second energy level. In Paschen series, electrons from the upper states come down to the third energy state. In this way, in Beck series, it comes down to the fourth energy state. In Cone series, it comes down to the fifth energy state. As is shown here, it is come down to the first energy state, to the second energy state, to the third energy state, to the fourth energy state. And principal quantum number 2, all these show principal quantum number 2, then their azimuthal quantum number, and then their magnetic quantum numbers, and corresponding to each magnetic quantum numbers, they have different electrons, either with plus of spin or minus of spin, plus minus of spin in this way. This is how Bob principle for 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d. Electrons will come initially in the 1s level, then to the 2s level, then it will fill 2p level, then it will fill 3s level, then it will fill 3p level. It will not go to 3D, but to 4s level. Then after 4s, it will go to 3D, then 4p to 5s. After 4p, it will not go to the 4D, but after completion, after going to the 4s level, it will then go to the 4D, then 5p, then 6s. In this way, this is your Aufbau principle. The periodic table of elements. If you go through the periodic table, you will see that the number, the elements are arranged in a way with regularly increasing atomic number from 1, then 2, then 3, then 4, then 5, then 6, then after a certain gap, the elements are showing similar properties. So elements those are showing similar properties, they are taken in the same group in the periodic table. And similar properties, they show according to the number of their outermost number of electrons in their outermost shell. So those electrons will which have same electronic configuration in the outermost shell will have similar atomic properties, similar chemical properties, and thus it will be placed in the same group in the periodic table. The elements are known as group. They vertically, which are placed vertically, they are said to be in a group, and in a period, which are kept horizontally. These are known as periods. The arrangement in period table and horizontal arrangement of elements in the period table are known as periods. Elements in the same group are placed in the same vertical line in the periodic table. The noble gases are the group of very unreactive elements, and the alkali metals are the elements which are very reactive metals, and halogens are placed in the second group, which are very reactive non-metals. Alkali metals are very reactive metals, and halogens are very reactive non-metals. From periodic table, we distinguish between metals, non-metals, metalloids, transition metals, alkali metals, alkaline earth metals, halogens, noble gas, etc. Then representative elements are the main group elements, and these are involved these are included in S and P block of periodic table. So S block elements and P block elements, all S block elements and P block elements are representative elements. The D block elements are known as your transition metals, and F block elements are known as inner transition metals, or lanthanides, actinides, etc. The vertical groups bring together elements with similar properties. The horizontal periods of the table are arranged, increasing atomic number from left to right, and when we go from left to right, its electronegativity increases, and when it goes from top to bottom, its electropositivity increases. S block elements and P block elements are the main group elements. They are known as your representative elements. D block elements are known as transition elements. F block elements are known as inner transition elements. And F block elements are from Z57 to above. These are known as lanthanides, and from Z, that is atomic number 89 and above, these are called actinides. Metallic and non-metallic character. Metallic character is the tendency of element to lose electrons, and whenever it is losing electrons, it absorbs energy, and this energy is known as energy. These are known as electropositive metals, electropositive elements. Metals are electropositive. The tendency of element to accept electrons, when they are accepting electrons, they lose energy, and this that the energy is lost when a gaseous atom accepts one electron, is known as the energy that is lost when it is electron affinity. So electron affinity, in case of electron affinity, the energy is lost, and in the case of ionization energy is accepted, that is, energy is gained. This is the definition of ionization energy, the definition of electron affinity, as I mentioned. And finally, chemical bonding. The attractive force between atom in a molecule is known as chemical bond. The tendency of atoms to form stable cell with 8 electrons is known as its octet rule. In case of helium, it is doublet rule. When atoms interact with each other by losing or gaining, sharing pair of electrons or donating electrons, it acquires some stability, and its outermost cell is they acquire octet configuration, and thus becomes stable. Chemical bonding between the atoms lowers the energy of the system, and thus imparts stability in the system. Types of bond. One is your electrovalent or ionic bond. It involves transfer of electron from one atom to the other. Covalent bond is formed by sharing a pair of electrons by two atoms. Coordinate bond is formed by coordinating one pair of electron, which is donated by a atom or group of atom, and it is accepted by another group of atom or atom at the central place, and the group or atom which is donating electron, this is known as ligand. Metallic bond is formed by sharing electrons of atom with electrons of so many other atoms. Thus, in a sea of electron, all the atoms of metal are lying, and they are sharing those electrons together, just forming a strong bond that known as your metallic bond. In addition to these bonds, some are weaker bonds like the hydrogen bond and the rose interaction. They are contributing in the bonding of atoms. When two oxygen atoms with three pair of electrons are combined together, two electrons from one oxygen, two electrons from another oxygen are shared, and oxygen and double bond is formed with a total octet of both the two oxygen atoms in final form. Polar covalent bond, where one is more electronegative than the other, then the electron greedy element attracts more electron towards it and becomes partially negatively charged, and as a result, the other atom becomes partially positive charged. Thus, the molecule becomes polar, and this form of bonding is known as polar covalent bond. Most chemical bonds are polar bond, and ionic bond and covalent bond are two extreme cases. Here, potassium loses electron and iodine is taking that electron. Thus, potassium becomes positively charged, iodine becomes negatively charged. So there is an electrostatic attraction between potassium and iodine, and this is your an electrovalency or ionic bond. Ions, the cations from metal and negative ions from non-metal are attracted with each other and form ionic bond. The bond is formed through transfer of electron. In case of your ionic bond, electrons are transferred to achieve noble gas configuration. Here you see that one very strong dog and another poor dog, weak configuration. Which were having one bone in their mouth, but the strong one is more greedy or stronger, takes the bone from the weaker one and becomes owner of two bones, and another lose that bone and are tied together. In this way, this is an example of your ionic bond. One is losing, another is gaining. In this case, one is stronger than the other, but not that stronger to pull the total bond from the other. Thus, one is taking more share of the bone, and another is just touching that one. And in this way, there is a polarity between these two, which exemplify the polar bond, polar covalent bond. These are the valence shell electrons, that is the outermost electrons in the outermost shell of these atoms. When two atoms of similar electronegativity comes together with their electrons closer, becomes share their electron and becomes a covalently bonded. And here it is a doublet in case of hydrogen, and here it is a octet in case of chlorine. In this way, they are sharing these electrons and getting stability to form the covalent bond. In case of your covalent bond, both are of equal energy, equally greedy, and they are taking share of these two bonds equally. And thus, in chlorine, it is showing the example of covalent bond. Between two hydrogen, it is electron sharing, they're forming a covalent bond. In this case, these two orbitals, s orbitals, are overlapping with each other. One is overlapping with the other, and thus forming the bond. In case of your oxygen, nitrogen, there is a double bond, here it is a triple bond, sharing 6 electrons in double bond, sharing 4 electrons. When two atoms are coming closer, at certain state, its energy is lowered, maximum lowered, and this is the bonding state. And when it is go further, then it is again its energy is increasing. From coming to the distant area, it is coming, and to the nearer end, this is the optimum distance where bonding is formed. So, electron in the atomic level, and they are forming bonding state, and this is anti-bonding state. When bonded, then they are overlapped with each other. When non-bonded or anti-bonding state, they become separate from each other. in case of your sigma bonding, two orbitals are overlapping axially, and two axial overlapping, they are forming bond like this. When two orbitals, pi orbitals are overlapping, not axially but in sidewise manner in this way, then there is a pi bonding. So sigma bond is more stronger, than the pi bond. These are something that are to be discussed with you regarding the electrovalency, covalency, coordinate valency, metallic bond, then other bonds, etc. So I think that you should go through this picture and other matters that are given to you, so that you can give answer to the assignment that are sent to